want to define fractions first, and then learn some rules and addition, subtraction, multiplication, division of fraction. So basically a fraction, if we identify it as a portion of something. When you have a whole, that's a piece of something. A fraction of it means a piece of it. For example, if I wanted to get, let's say, 2 out of 5 of this, I wanted to get 2 out of 5 of whatever this piece is, okay? What should I do first in order to get 2 out of 5? First, you want to divide that whole piece into 5 equal pieces. And then you take 2 out of them. So 2 over 5, or 2 out of 5. So let's divide that into 5. So it'll be 1, 2, 3, 1, 2, 3, 4, 5. Okay, so we divide it into 5. Then we take 2 out of them. We're going to shade this one, for example. Shade another one. So this shaded area represents 2 out of 5 of this whole piece. So fraction is portion. Fraction means portion of something. Okay, so the shaded is 2 out of 5. What's the fraction of the non-shaded parts of this piece? What's the fraction of the non-shaded? That's the opposite of 2 over 5. What's left is, can you guys hear me?
Yes.
Okay, so if 2 out of 5 is what's shaded out of this whole piece, what's the fraction of the non-shaded part?
3.
3 out of?
2. Out of 5.
Out of 5. That's right, we have 1, 2, 3 out of 5 pieces.
Yes.
Not shaded. So that's the whole idea of fraction. You would just take a piece of pieces out of some whole or some other pieces. For example, here we have 2 out of 5. And each fraction has 2 parts. So a fraction is made of 2 numbers, A over B. The top number has a name, and the bottom one also has a name. What do we call those numbers? A and B. A is the numerator.
And B the denominator.
Over, what's the bottom part?
Denominator.
That's right, the denominator. Okay, and that's basically the definition of fractions, a lot of concept of them. And now we're going to move on and see, talk a little bit about simplifying fractions. But before that, we need to learn something called factoring. Factoring numbers. So it's very simple. When we talk about factoring a number, for example, 15, we're just basically breaking it down into multiplication of numbers that multiply to 15. What numbers multiply to 15?
3.
3 and 5.
2.
Okay.
Yeah, 5, sorry.
Okay, so 15, 6, and 5. We call these factors. 3 and 5 are factors of 15. 3 and 5 are factors of 15. And some numbers can be broken down, others cannot be broken down. So there's a difference. Let's take 18. Can we break it down? 18, we can write it as, if we break it down as a multiplication, what would that be? Could be 9 and 2. Then we continue and see if we can break the other numbers down. We can write 9 as what?
1.
9, we can break it down into what numbers?
9 and 1. Oh, sorry.
4. Or 3 and 3, okay? And 2, we cannot break 2 down. It's just 2 times 1, or simply 2. Okay, so again, so we just factored 18. These are called the prime factors of 18. So these are called prime factors.
Okay, so Professor, I have a question.
Yes.
When you're finding the prime factor, for example, with 18, you find two numbers that could be two numbers that multiply and give you 18?
That's right. And then if you keep going down, if you can find 2 other numbers you can break down this number into, you keep going until you can't divide it anymore. So we can't break
Okay.
the 3 down, you can't break the 3 down and the 2. That's how you know you get your prime numbers, prime factors, basically numbers that cannot be broken down.
Okay.
Okay, so some numbers can be broken down, other numbers cannot be broken down. For example, 17. Can you break the 17 down into something else other than 17 times 1? You cannot find two numbers,
Nope.
two whole numbers that multiply to 17. So basically 17 is called a prime number. Just like 3 and 2 here, they're prime numbers. So is 17. Can't be broken down. Unlike 15 and 18, 17 cannot be broken down. Okay, because we call this a prime number. These 15 and 18 are called composite numbers because we can break it down, break them down. So 15 and 18 are composite numbers. Composite, not prime. Okay, does that make sense?
Yeah.
All right, so that's basically what factoring is. It could be a large number. Doesn't matter how big it is, you just keep breaking it down until you can't divide anymore. And you call that a prime, or the numbers you get are called prime factors. This one here is a prime itself. It cannot be broken down. You can only say 17 times 1, which is not much. So basically a prime number can only be divided by itself and 1. Okay, prime numbers can only be divided by themselves and 1. Okay, now that we learned what factoring is, we're going to see how to use it to simplify fractions. So that's the whole reason why we learned this, so we can use it in simplifying fractions. Let's call that number 3. So simplifying fractions. Okay, if you have, for example, 15 and 18, 15 over 18, that's a fraction. We always try to reduce this to possibly a smaller fraction. We do so by factoring the top, factoring the bottom, and we cancel out any common numbers between the top and the bottom. For example, here, what's 15 again? We already factored it here. 15 is basically just 3 times 5, you can say here. 3 times 5 over 18. 18, what is 18 again? 18, we broke it down into 3.
2 times 2.
Right, so if you write those here, now what do you think happens? We can cancel any common factors between the top and bottom. 1 against 1, okay? Cannot be 2 against 1, 1 against 1. For example, we cancel this 3 against this 3. What's left? Just 5 over 3 times 2, that's 6. Okay, so this is a much simpler fraction. So we just simplified this fraction into a new one. We call these equivalent fractions. Call them equivalent fractions. Oh, it's really hard to write on this thing. this one, 15 over 18, and 5 over 6, are called equivalent. It's technically the same ratio, the same division, it just one with smaller numbers. But if you divide this, for example, in the calculator, you divide this in the calculator, the result is exactly the same. So that's why we call them equivalent fractions. So any fraction with large numbers can be, it's possible to simplify it into something smaller. That's the reason why we used factoring, so we can see what's common. Sometimes you might not need to do this part. Some of you can do it right away. You just look at the numbers. You say, oh, 15 into 3 goes into both. You say 3 into 15, 5, 3 into 18, 6. You just write 5 and 6. You don't have to write this middle step, but until you get used to it, you may want to bring the numbers down until you get something that's simplified. Here's another example. 14 over 21. Again, we want to simplify this. Also, we may say reduce to the lowest terms. Reduce to lowest terms. They basically mean the same thing. Reduce to lowest terms is the same as simplifying. You just take a fraction and you reduce it into something like this, simplified, or to the lowest terms. Always start again by factoring the 2. So we can factor 14 into what? What number is multiplied to 14? Everybody, how do you break down the 14?
7
and
times
7.
2. 7 times 2.
Exactly, 7 and 2. And for 21, it will be?
7 times 3.
Exactly. So we factored it. Now what happens? What do we do next?
So,
Cross out the
14 over 21.
We already have that. We're trying to make this smaller, reduced it. We try to reduce it, so we broke it down. Now, what do
So
we do?
you cancel out the 2 7s?
Exactly. We're going to reduce by 7 because it's a common factor. It's here and here. We cancel it out. And the result is just
2/3?
Over 3.
2/3, exactly. So 14 over 21, if you didn't know, it's basically just 2/3. And it's much easier to deal with simplified fractions. So if I said, give me 2/3 of something, you know you're going to divide that thing into how many pieces? Into 3 first, right? And how many pieces do you take out of that? How many pieces out of that do we take to get 2/3? 2, right? 1 and 2. This is 2/3. But if I said 14, give me 14 over 21 of something, it might not make sense. Okay, it may not make sense. You will have to take a piece and divide it into 21 parts and then take 14 out of those. That seems like a lot of work. That's the reason why we simplify fractions. This is much nicer and easier to understand and work with. Okay, so that's basically what we mean by simplifying fractions. Let's move on to another concept. Now we're going to talk a little bit about mixed numbers and improper fractions. Okay, so let's call this number 3 or number 4. Types of fractions. You have 2 types of fractions. If you have a fraction in general, for example, a over b, depending on which number is higher, the fraction could be. If a is smaller than b, if a is less than b, what kind of fraction is it? When the number at the top is smaller than the bottom, it's called a proper fraction. Okay, but sometimes the top number is not less than, but instead it's higher than. If a is greater than b, what kind of fraction is it?
Improper.
That's right, the opposite of proper is improper. Improper. improper fraction. Example here, let's say 1/2, 7/8, 11/13, and so on. All these are proper because the top is smaller. 1 is smaller than 2, 7 smaller than 8, and so on. Give me some examples for improper fractions. An example?
Example 25/14.
That's right. The top is higher, so that's improper. 25/14 here. Or maybe 7/3. Probably 5/2. All these are improper because the top is higher than the bottom. Okay, now that we know what proper and improper fractions are, with improper fractions, we can actually turn them into what we call mixed numbers. So we're going to convert. Okay, so we're going to take improper fractions and we turn those into what we call mixed numbers. Let's start with this easy problem here. So 7/3 is a fraction. The numerator, which is 7, is higher than the denominator 3. There's another way to write this. Instead of writing it as a fraction, we can write it as a mixed number, a number with two types of numbers. So to do so, you just say, how many times does 3 go into 7? Okay, how many times does 3 go into 7? Even times, how many even times?
3 go into 7 twice.
That's right, so you say 2. But it doesn't go evenly into 7. There is something, some left over, right? What's the remainder?
Right.
How much?
2.
So 3 goes into 7 twice, which is 6. How much is left from 7?
Oh, sorry, 1.
1, that's right. So the remainder is 1. Remainder. And what goes here?
3.
That's right. The same denominator, you bring it over to the other mixed number. So this 3 goes here. So again, 7 into, or 3 into 7, or 7 divided by 3 is 2. But 7 is a leftover of 1, the remainder. And, or the remainder, right? Remainder, actually, remainder. So the resultant mixed number is 2 and 1/3. 2 and 1/3. So you start a letter fraction, you write the 2 first, and that letter fraction is somewhere in the middle of the number, not at the base, not here. Otherwise, it would look like a multiplication of the whole number and the fraction. Instead, it's a letter fraction in the middle of the number, and you write your mixed number here. So you say 2 and 1/3 is the answer to that. Okay, so any improper fraction could be turned into the mixed number. So this is the mixed number here. Okay, let's do another one. Probably this one, 5/2. So this is 1, let's do another one. So how many times, again, does 2 go into 5? 2 into 5, how many times?
Twice.
It's twice, so that's the whole part. So this is the whole number, and this is the fraction. That's why it's called a mix. It's a mix of a whole number and the fraction. And here, so what is the remainder? If
1.
1, that's right. And the denominator here will be
2.
2. So 2 and 1/2. Okay, that's a mixed number. That's a fraction. Let's try to do this first one. So that's 25/14. How many times do you think 14 goes into 25? Is it twice? Wouldn't be enough for twice.
No, so
Twice,
it's 1.
twice 14 would be 28. So it doesn't even, it only goes once. So I'm going to write 1. A little fraction in the middle of 1. Same denominator, 14. What's left from 25? How many points are we shy from getting it twice? 3,
9. I think 9. I'm not sure.
11, I think.
11. 11 is better. Okay. That's right, because if you add these two, you get 25. If you add 11 and 14, it's 2, 5, you get twice. Okay, so 1 and 11 over 14. You can also do the division on the side. If you can't see the numbers, you can always do the division. So 25 goes, the top always goes inside, even if it's smaller. You do the 14 here. Then you say 14 into 25, that's 1, times these two, that's 14. And if you subtract, you get 11. So that's the remainder, that's the R, the remainder, that's what basically goes here. The result, or the quotient, is what goes here. And of course, this the fraction is this number. Always stays the same. The fraction here is also the fraction in the mixed number. Okay, that's how you turn improper fractions into mixed numbers. Now we're going to do the opposite. We're going to start from here and go back to a fraction. We're going to see how to turn. So now we're going to do mixed numbers into improper. So mixed numbers to fractions or improper fractions. Let's start with this one here. So we want to turn that into this. What do you think we do to this fraction, this improper number, or this mixed number, to turn it into a fraction? How do you get?
You multiply 2 and 3?
That's right. So to get this number, you've got to times these two together and add the remainder.
Right.
Okay, you're going to times 2 times 3. That's 6 plus 1, you get 7. And then, let me see. Okay, so, and the remainder stays the same. So you do 2 times 3, 6 plus 1, 7. You bring the same number here, 3 stays the same. Yeah. Same thing here with the 5 over 2. So to get 5, so to go back to the fraction, you times these two, 2 and 2, 4 plus 1, 5. You get this. And you bring the same denominator here. So let's make up some problem. Let's say 3 and 1/4. That's a mixed number. How do you turn this into a fraction?
You multiply 3 times 4.
That's right. 3 times 4, and what else?
And then you add 1, so
exactly, we add the 1.
12, that would be 13.
Okay, so we times these two, and we add the remainder. What's the
4?
The denominator stays the same. Okay, the denominator always stays the same whether you go in from mixed to proper or the other way. So 4. Now we simplify this. The order of operations is multiplication first. This is 12 plus 1 is 13 over 4. As you can see, so that's a mixed number. That's an improper fraction. Only improper fractions can be turned into mixed numbers. Proper ones cannot be turned into mixed numbers, because if you have a proper fraction, like this one, 2 doesn't go into 1. 7 doesn't go into 8. 13 doesn't go into 11. That's why you don't have that whole part. 13 goes into 11 0 times. So the whole part basically is 0. So we don't need to write that into as a mixed number. Okay, so that's that. Now let's see how to multiply fractions. The other part today. So 4 type of fractions. Number 5, multiplying fractions. We're going to do the addition and subtraction next class, because it takes a little longer. There's a few things we need to learn, including the LCD. But multiplication and division of fractions are relatively easier, so we can do that today. So in general, when you times fractions, let's say you have 2 over 3 times 1 over 5. What's the rule here? How do you multiply two fractions?
You cross multiply?
What do you mean by cross multiply? Give me the numbers here.
So you do 3 times 1 and 2 times 5?
Okay, so you don't cross multiply. You actually multiply straight across.
Okay.
Okay, you just multiply this way. So 2 times 1 over 3 times 5. That's 2 over 15. Okay, it's pretty simple. Sometimes you may need to simplify. So if you have, for example, 14 or 15 over 8, and you want to times this by maybe, let's say 5, and you have 4. So you can always multiply straight across. But it's easier and it's more convenient to actually reduce the fractions first. We can reduce these before doing 15 times 4 and 8 times 5. We want to see if we can make the numbers smaller as we did earlier. Remember when we reduced fractions here? For example, here and here, it would be easier to times this and this instead of multiplying this and this. So we're going to try to simplify our fractions. Once we have something smaller like this, we can multiply it right away. But if you're going to multiply 15 and 14, 18 and 21, it's going to be a large fraction, and you still have to simplify it at the end. So why not simplify it first, save time and everything before the numbers get bigger. So let's start with this fraction. Can you reduce this fraction on its own? 15 over 8. Is there anything that goes into both? Nothing goes into 15 and 8, right? Same thing here, 5 and 4, nothing goes into both. If we can't simplify this way, then we're going to try to cross simplify. See if we can simplify this way. 15 and 5, what goes into both?
3?
Not 3. It's 5. 5 into 5 once. Okay.
No, I've confused myself by thinking 3 times 5 is 15.
Yeah, you were thinking about 3, I understand.
Yeah.
5 into 5 once. 5 into 15, how many times?
3 times?
3 times. And then you simplify this way. What goes into 8 and 4? The highest number. Not just 2, but a higher number would be 4. So 4 goes into both. You can say 4 into 4 once. 4 into 8, how many times?
Twice.
Twice. So it's much easier now to multiply these numbers, 3 and 1, after we simplified them. 3 times 1 over 2 and 1. So that's 6. 3 over 2. See, we didn't even have to do the multiplication with large numbers. You don't have to simplify the fraction. You end up with a simple fraction at the end. So always reduce your fractions as much as possible before multiplying them. Okay, so that's basically how the multiplication of fractions work. So multiply straight across and reduce first. Always reduce first, it's important. If you don't reduce now, you're gonna end up with a large number and you still have to simplify it. So better to reduce first. Now let's do number 6, division. So a little bit different. I mean, just one extra step, but it's gonna come down to this. So division. So here's what you do. When you're multiplying, when you're dividing two fractions, let's say 1 over 2. So with multiplication, you just multiply straight across. With division, you want to actually turn it into a multiplication first. So we're going to turn this division into a multiplication and then do the same thing as we did earlier. So to do so, we do what we call keep, change, and flip. That's right. We keep the first one untouched. We're going to turn or change the division into a multiplication, like so. And we flip the second one only. Flip upside down, we get the reciprocal of it, which is this. Now, once we turn it into a multiplication, we know how to multiply fractions, just multiply straight across. So this will be 8 over 3. But again, always try to reduce first. Nothing goes into these, nothing goes into these, so we just get this at the end. 8/3. So division is quite similar to, I mean, if you turn it into a multiplication, then you repeat basically the same steps. So that's how division works. Let's do an example now, maybe with a mixed number. Let's say you have 3 1/2, and we want to divide that by, let's say, maybe 5. We have two different numbers here. We have a mixed number, we divide by a whole number. So what we'll do is we're going to turn both of these into fractions. How do you turn this one again into a fraction?
You keep the first one.
Now, before we keep change flip, we need to make both of them fraction.
Oh, we have to multiply 3 times 2.
Exactly. 3 times 2, 6, plus
6
1, 7,
7
over 2,
2.
right? We don't flip yet. How do you make 5 into a fraction? Just say 5 over
1.
1. That's right. Now that we have two fractions, to divide, we're going to repeat the same process as here. Keep change flip. So 7 over 2, multiply. What's the reciprocal of 5 over 1?
1 over 5.
1 over 5. And that's it. Your multiplication is done. Try to simplify. Nothing simplifies here. So it'll be 7 over 10. Okay, so make everything fraction first. If it's not a fraction already, then if it's multiplication, just straight across, multiply straight across. If it's a division, keep change flip. Keep the first one, change this into multiplication, and flip the second one, then multiply. At the end, try to reduce if possible. Nothing reduces here. This is improper, this is proper, nothing reduces. Okay, does that make sense?
Yes.
All right, very good. Naomi, good?
Yes.
All right, that's very good. That's pretty good. That's pretty much it for today.
Okay.
Let's do some, we're gonna go over to Blackboard now, to the discussion board, and we'll continue with the lesson plan. I will show you the homework, and we'll answer any questions you may have there, okay?
Okay.